welcome to PhysChem with Liz. I'm Liz, and in this short video I'm going to show you how to interpret an infrared spectrum. What you'll need is a datasheet, and to illustrate this I've got a past paper question. It's actually from one of the OCR practice papers in 2016. So all datasheets, no matter which exam board you're studying, they're all pretty much the same. If you turn to page 2, you'll find a table of infrared absorptions. Now, from here down, these are all functional groups, the reactive part or the reactive bond in a molecule. And this is how we classify molecules, so halogenoalkanes, alkenes, the carbonyl is in ketones, among other things, nitriles, alcohols, acids, and so on. So all of these bonds have characteristic absorptions. So they absorb infrared at different energies within the infrared region. And we're going to use this to interpret this graph. So this plot of transmittance, so remember transmittance means the wavelengths that pass through without being absorbed, they're transmitted. So it's a graph of transmittance against wave number, which is just energy. And that gives us what's called the infrared spectrum. So in this question it says we're looking at a compound present in a sample of ink, and we're given elemental analysis, so we can get empirical formula from that. We're given mass spec. We've got an M plus peak, which tells us the relative molecular mass of the whole molecule, so we can see if that empirical formula is the molecular formula. And we've got an infrared spectrum. So this technique is often combined with other techniques to make it more useful. But let's focus on this graph to begin with. So notice on the x-axis of wave number, we start from the bigger wave numbers and go down to small ones. And notice the units of wave number, centimeters minus 1. And transmittance is percent, and it goes from 0 to 100. So up here, you can see that at this energy, at this wave number, not much radiation is being absorbed. Nearly all of it is passing through, it's being transmitted. Almost 100% is being transmitted. Then we've got a bit absorbed here, around 3000. Now this is what's called a sharp peak, or trough if you like, and that tells us that it can't be an OH, because OHs are broad, so in other words they're fat, they're curved due to hydrogen bonding, so it's likely to be due to a CH bond vibration. So we'll label that. Oops, sorry guys, just trying to pick up the pen. CH. Then we've got a bigger absorption, so a bigger peak or a bigger trough, around 1750. Now that's a characteristic peak for, here we are, a carbonyl. So let's label that peak. And this is what we do. We look for characteristic absorptions, big peaks or troughs. We find the range at which they appear on our table, and we just annotate the graph. So we're going to label it CO. Just get the pen. CO. Now, one thing I haven't mentioned yet is that everything below 1500 is what's called the fingerprint region. So this means that this region is characteristic of a specific molecule. So this pattern can be scanned by a computer and we can match it to a specific molecule by comparison. However, below this wave number, the peaks all merge together and we cannot identify peaks in this region. So do not try to look for any of these peaks and match them up using your data table. So I'm just going to annotate that fingerprint region. So that's the first example. That's how an IR spectrum looks. That's what we do. We label the peaks on the left hand side of the spectrum that are above 1500 in wave number. Only the major peaks. We ignore that little piffly thing up there. Not interested in that. And it tells us what groups are in the molecule. We've got other information which we're not going to do much with today. Well, we're not going to do anything with it. Elemental analysis. So we can look here. Does what we labelled seem sensible? We've got carbon and oxygen. We've labelled it as a carbonyl. Yes. We've got carbon and hydrogen. We labelled this as CH. Yes, it does. I hope that was helpful. If it was, please like and subscribe, and I'll see you again soon. Bye.